OsaiIO module, sometimes known as the OsaiRing. The problem with this one right here is we have a green and red light here. The red light's not coming on, and the green light comes on, goes off, and then it takes a while for this unit to warm up before everything comes up normal. We're going to go inside and see what we can find. There's all the cover screws removed. Slide this back just a skooshy bit. There we are. We're inside. Here's the output relays right here. We're going to disconnect this ribbon cable so that we can move that out of the way. I'll show you how to test this bank of relays here in a little bit. Right now what we have to do is remove the control board. We have screws here that we need to remove. Almost there. This will slide out. Move the housing out of the way. I'll set these screws in the housing so I don't lose them. Ain't nothing like trying to hunt down a screw that you had. I do it all the time. I hate doing that. I know I had that screw, where'd it go? So I try to keep everything together. Right here is the field programmable gate array. This one here is made by Lucent. Its part number is 3042-70. Xilinx makes these. I've seen an OsaiRing in here with an AT&T FPGA. They all are identical in function. Over here is a configuration IC. When you power up this board, the configuration IC programs, it sends its data into the FPGA to set it up. Every time you power this up, it gets programmed. The FPGA gets programmed by that configuration IC. Here are the input modules. You have output over here on the relays, input here on the input hybrid modules. Here underneath these green and red LEDs is a connector. This is where the power comes in. It gets rectified to DC and sent to this DC to DC converter. Its part number is GS-R405/2, made by ST. it converts that DC coming in, rectified here, DC coming in, to 5 volts for the logic. Now what we'll do is I'm going to apply 24 volts DC to that input connector. The polarity does not matter because the rectifier, the bridge rectifier here, will convert it to the proper polarity on the output side. You know, I'll do a video on that and I'll show you how that works. How this bridge rectifier can take DC in either way. I'll show you that in another video. That'd be a simple video to do. Alright. We're going to take 24 volts DC from this power supply right here, and we're going to look at the 5 volts and make sure that the 5 volts is good. There's a axial electrolytic capacitor right here, and I always clip the oscilloscope ground to that ground side of that axial electrolytic capacitor. Let's turn our scope on, and we'll get close to the oscilloscope and we'll see how that 5 volts looks when I power it up with this power supply right here. Give me a minute to get this camera over there in front of that oscilloscope. Can y'all see that okay? Let me grab the probe over here. Just turned on the OsaiRing, and the green LED is flashing and the red LED is off. Let's take a look at the 5 volts. Bring that back in. There, look at that. The DC to DC converter is starting up and then dropping off. So what we've got to do, we've got to get a new DC to DC converter. Look at that. That's supposed to be a clean 5 volts DC. There's the problem with this OsaiRing, bad DC to DC converter. Part number GS-R405/2. We're going to have to get a new one of those. Let me power down, and here in a moment I'll show you how to test that bank of relays on the output side of the OsaiRing. Turn the scope off. We don't need to be wasting electricity if we're not using it. Here's my drawing of the relay output board right here. Now on the ribbon cable, we're going to apply 24 volts DC. Now we can put it on any of these pins, 31, 32, 33, or 34. Here's a ceramic capacitor right here from plus 24 to ground. Ground is on 25, 26, 27, 28, 29, or 30, and 30. So we're going to put 24 up here and ground right here from an external power supply. Here is one drawing of one relay, resistor, and LED. Now, I didn't want to draw all of them. There was no need. They're all the same. Here's the relay coil right here. Common of all the relays is plus 24 volts DC. You turn it on by pulling pins 1 through 24 to ground, this ground right here. When you do that, current flows from plus 24 to the ground of that external power supply, and it turns on this green LED that represents this relay turning on. That helps in troubleshooting in the machine. Let's say you know that relay 1 was supposed to turn on, but you didn't see relay 1's LED on. You would know that that relay wasn't turned on by pulling pin 1 to ground. So let's hook it up and test it. Get our 24 volts DC connected to that ribbon cable. This JP1 jumper right here connects ground to frame ground, so I'm going to clip the external power supply to that. Now, pin 1 of this ribbon cable is right here. You can see a diamond on the connector representing pin 1. They alternate, so pin 1 is on this side, 2 is on that side, 3 this side, 4 that side, all the way up to the 34th pin right here in this corner. So I'm going to connect the power supply to pin 34 right there. Now we're all connected. What we have to do now is have a way to connect these pins to ground to turn on that relay. I got this little wire right here with a socket on the end, and we're going to connect that to pin 1. Now I like to put a jumper down in that connector so I know where the last input is to turn on the last relay, and the last relay is on pin 24, so I'm going to set this jumper on pin 25 and 26, and that's right here, and that jumper just tells me where the last input is. The inputs are from 1 to 24, pins 1 to 24. So there's 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. We'll connect this to ground, and that is how we're going to connect the relay coil to ground. Let's turn that on. Hear that relay clicking? That relay's energizing when I pull pin 1 to ground. Let's take a look at the front, and you'll see the LED turn on. I first like to go through all the inputs to make sure that the relays are energizing, you can hear them energize, and that all the LEDs turn on. I heard all the relays energize, and I saw all the LEDs illuminate. Now we want to check the contacts of the relay. I'm going to move the camera again and show you how we do that. I have this 6 contact Phoenix connector that I'm going to use to easily apply my flute DMM probes to. Now, there's 2 rows of this connector, as you saw in the last frame. There's a top row and a bottom row. So you have 2, 4, 6, 8, 10, 12 connectors that we have to go through. I start out on the bottom row. With the camera angle we have here, it's going to look a little strange because it's going to look like I'm testing the same connector twice, but I'm not. Here's the bottom connector right here, and here's the top connector. Now we go through all the bottom row first, and then we come back up and do the top row. You want to tighten up the screws on your connector that you use so that you don't get false reads. If the screw terminal is backed all the way off, we won't have good contact with the pin on the relay board. So let's insert that all the way. We have 2 relay contacts on this one connector right here. So here we have relay 1 on the first 3 and relay 2 on the second 3. This is common and normally open and normally closed. We're going to set the meter right there. I'm not going to go through all of the test. I'm not going to on this video right here. Once you know how to test one, all of the others are the same. So I don't want to bore you with watching me go through all 12 connectors right there, all 24 relays. Let's apply 24 volts DC, and this is the common. First pin is the common, second is the normally closed, and you can see we have continuity. The third contact is normally open, and that's for relay 1 right there. Now we're going to go look at relay 2. Here's the common, and then here is the normally closed, and here's the normally open. Now I'm going to close relay 1 by applying ground to pin 1 of the ribbon cable. Common, normally closed is now open, and the normally open to common is now closed. We've energized that relay. Let's move to relay 2. Now you want to make sure that relay 1 is de-energized. Yes, it has. Now let's go to relay 2's contacts. Let's common to normally closed is now open. Common to normally open is now closed. That relay is energized. Let's move to the next connector, and we're going to check relay 3 and relay 4. First, let's check the normally closed contacts. Common to normally closed is closed. To normally open is open. Relay 4, common to normally closed is closed. And to normally open is open. Let's energize relay 3. Okay. Common to normally closed is now open, and normally open is now closed. We'll go to relay 4. Let's make sure that relay 3 de-energized. Yes, it did. Here's relay 4. Normally closed is now open. And common to normally open is now closed. And we go down the row for all 24 relays by moving that contact to ground. Now what happens if you have a bad relay? When, for instance, we look at the normally closed contact right there, we can see we have 0 ohms of contact resistance. But if we had a bad relay, that would show open, or 500 ohms, or 1 kilo ohms of contact resistance, or 1 mega ohm of contact resistance. We would have some contact resistance right there. Same with going to the normally open contact right there. You can see we have 0 ohms on relay 4 of the common to normally open. But if when we energize that relay we had high contact resistance or infinity contact resistance, we would have to change that relay. These relays are enclosed right here. They're encapsulated. We can't get inside them to clean the contacts. I'm going to go through the rest of the board, testing all of the relays, and if I find a bad one, I'll fire up the camera again and show you. But otherwise, that's how you test the OsaiRing relay output board. At the end of this video, I'll put up that drawing I have of how to test the relay board. When I get a new DC to DC converter in, I'll show you how to test the input hybrid modules. Can't do that until we get good 5 volts on that control board over there. They don't work when that 5 volts is all over the place. Okay, hopefully I've got all good relays, but if not, we'll show you what a bad one looks like. Alright, the first thing we're going to look at is applying the 24 volts DC and ground to the 34 pin ribbon connector. Up here is 31, pin 31, 32, 33, and 34. That's where you apply the plus 24 volts DC to that ribbon connector on the relay board. Now you can connect ground to 25, 26, 27, 28, 29, and 30 of that ribbon cable connector, but I always clip it onto this jumper wire. This jumper connects ground to frame ground, and it's just a real convenient place to clip that ground lead to. Now let's run down and we'll look at the relay and the LED connections. When I'm at the shop and I got my camera set up, I don't realize how far away the camera is from my schematic drawings. I'm going to get me a new cameraman. Well, wait a minute, Peepaw. You are the cameraman. You can't get rid of yourself. So, when I get to the house, I try to get close to everything so y'all can see it. Oh, man. One day I'm going to get me a good cameraman. No, you can't. You are the cameraman. All right. Here's the relay. And this 24 volts that we applied to the relay board is common to all the relays on one side of the coil. The other side of the coil needs to get pulled to ground of the external power supply that we apply to that relay board. And when we do that, the relay is energized and you can hear it click. And you can check continuity of the contacts. I'll put up a drawing of the contacts here in just a skoshi bit. When the relay is energized, current also flows from plus 24 volts through the 10 kilo ohm resistor, through the anode to cathode of the LED back to ground, and illuminates that LED. So you know when that relay is energized, this LED is turned on. Let's take a look at the contacts. Let me draw that out here in just a little bit, and we'll turn the camera back on. Okay, here's the green Phoenix connector, and each connector has 2 relay outputs. This first pin right here is common, the second pin is normally closed, and the third pin is normally open for the first relay on that connector. The 4th, 5th, and 6th are the common, normally closed, and normally open contacts of the second relay on that connector. And up here I got a little drawing of each relay contact. So here's common to normally closed contact. When we energize that relay, the contact swings from common to normally open. C is common, NC is normally closed, and NO is normally open. Same with the second relay on that connector. Isn't that amazing? That's amazing how you can take and control the outside world with a simple relay like that. Alright folks, it's getting dark around here. We ain't come out of winter yet. Stay warm, and we'll see you next time.